Have you ever pondered about the nature of our universe? It's a question that has perplexed thinkers, philosophers, and scientists for millennia. From the dawn of civilization, we've looked up at the night sky, awed by the vast expanse of twinkling stars and celestial bodies. The universe, in all its grandeur and mystery, has always been a source of fascination. Over the centuries, countless theories have been proposed to explain the nature of the universe. The ancient Greeks believed in a geocentric model, with Earth at the center of the cosmos. Nicolaus Copernicus in the 16th century revolutionized our understanding with his heliocentric model, placing the Sun at the center of our solar system. In the 20th century, Albert Einstein's theory of relativity further reshaped our comprehension of the universe, introducing the concepts of space-time and gravity. Edwin Hubble, with his observations of distant galaxies, gave us a glimpse of an expanding universe. While these theories have greatly advanced our understanding, they've also left us with more questions than answers. The universe, it seems, is far more complex and mysterious than we could have ever imagined. In recent years, a new, intriguing idea has emerged. What if our universe, with its galaxies, stars and planets, is not what it appears to be? What if everything we perceive, everything we touch, feel and see is merely a projection? This is the concept of the holographic universe. The holographic universe theory proposes that our three-dimensional reality is a projection of information encoded on a distant two-dimensional surface. Much like a hologram, it suggests that the universe we experience is simply an illusion, a sophisticated projection from the edge of the observable universe. Could our universe, in all its vast complexity, really be a hologram? It's a question that challenges our understanding of reality and pushes the boundaries of human knowledge. As we delve deeper into the mysteries of the cosmos, we may find that the true nature of the universe is far stranger than we could have ever imagined. Imagine a holographic image. Now imagine that on a cosmic scale. To simplify, let's take a step back and consider a holographic sticker. You know, the ones often found on credit cards or event passes. They look flat, right? But tilt them under a light, and suddenly a three-dimensional image pops out. It's as if a whole new layer of depth is revealed. Now here's the kicker. That 3D image you see, it's not truly three-dimensional, it's a trick of light, an illusion. The image is actually encoded on a two-dimensional surface, the sticker itself. But with the right angle and lighting, it gives the impression of depth, of a third dimension. This is the essence of a hologram, a 3D image encoded on a 2D surface. Fascinating, isn't it? Now let's take this concept and think bigger, much bigger. Let's think about the universe. Yes, the entire cosmos. With all its galaxies, stars, planets, and the vast, seemingly infinite space in between, it's a three-dimensional world we live in, right? We can move forward and backward, left and right, up and down. But what if this reality is an illusion? What if our universe, in all its three-dimensional glory, is actually a hologram? Just like the 3D image on the sticker, our universe might be encoded on a two-dimensional boundary. That's the boundary of the universe itself. All the depth and volume we perceive could be an illusion, a holographic trick on a cosmic scale. Does this mean our reality is fake? Not necessarily. It simply suggests a different understanding of the universe's fundamental nature, a revolutionary concept that challenges our perception of reality. If a simple sticker can contain a 3D image, why couldn't our 3D universe be encoded in its 2D boundary? Opening. What would it mean if the universe was indeed a hologram? Imagine for a moment a two-dimensional surface, like a piece of paper. Now, imagine if this simple, flat surface could contain all the information needed to project a fully formed, three-dimensional reality. Sounds like science fiction, right? But this is the essence of the holographic principle, a theory that suggests our universe could be just like this, a holographic projection. But how does this work? Well, think about a standard hologram, like the one you might find on a credit card. When you look at it from different angles, you see different images. Each point on the hologram contains information about the whole image. It's a two-dimensional surface, but it gives the illusion of three dimensions. In a similar fashion, The holographic principle proposes that our universe, with its 3 dimensions of space and 1 dimension of time, is actually a projection of information stored on a 2-dimensional surface. This surface is thought to be the boundary of the universe, or the cosmic horizon. So in essence, everything we perceive around us, from the stars in the sky to the chair you're sitting on, could be a projection from this cosmic horizon. But what does this mean? Well, if true, the implications are mind-boggling. It would mean that our perception of reality is merely an illusion, a holographic image projected from a distant cosmic horizon. It would also imply that space and time are not fundamental aspects of reality, but rather emergent properties resulting from the laws of quantum mechanics operating on this 2-dimensional boundary. This theory challenges our intuition and shakes the very foundations of our understanding of the universe. It forces us to reconsider the nature of reality itself. But it's important to remember this is just a theory, and like all scientific theories, it's subject to ongoing testing and scrutiny. Closing. In a holographic universe, the whole is in every part. As with any theory, evidence and skepticism walk hand in hand. In the realm of quantum physics, there is a growing body of evidence that supports the holographic principle. This principle suggests that all the information which is contained in some region of space can be represented as a hologram, a kind of 2-dimensional description of the universe. One of the most compelling pieces of evidence comes from the world of black hole physics. Here, renowned physicist Stephen Hawking and his contemporaries have proposed that the information about everything that falls into a black hole is actually stored at the event horizon, the boundary around a black hole from which nothing can escape. This information storage, they argue, is akin to a holographic projection. On a more cosmological scale, the study of the cosmic microwave background radiation, the afterglow of the Big Bang, has revealed anomalies that are best explained by the holographic principle. These irregularities in the cosmic background radiation provide an intriguing hint that our universe might indeed be a hologram. Yet with evidence comes skepticism. Critics argue that the holographic principle, while mathematically fascinating, is yet to be directly observed. It remains a theoretical construct, more at home in the realm of abstract equations than in the observable universe. There's also the issue of scale. While the holographic principle might hold true at the quantum level or for black holes, does it apply to the universe as a whole? This is a question that continues to confound scientists and provoke debate. Furthermore, the concept of a holographic universe raises profound philosophical questions. If the universe is a hologram, what does that imply about the nature of reality itself? Is our 3-dimensional world merely an illusion? These are questions that science is yet to answer. Despite the skepticism, research in this field is ongoing. With advancements in technology and our understanding of the universe, we inch closer to understanding the true nature of our reality. Perhaps one day we'll have the tools to definitively prove or disprove the holographic principle. Evidence and skepticism both are crucial in the pursuit of truth. So, where does this leave us? As we contemplate the idea of a universe that may be holographic, it's important to reflect on the implications this could have for us, not just scientifically but philosophically as well. Firstly, let's consider the scientific implications. If the universe is indeed holographic, this would mean a complete paradigm shift in our understanding of reality. We'd have to rethink what we know about space, time, matter, and energy. The laws of physics as we know them would need to be revised. It could potentially unlock new ways of understanding quantum mechanics and general relativity, two theories that have long been at odds with each other. The philosophical implications are equally as profound. If the universe is a hologram, then what does that mean for us? Are we also holographic? And if we are, what does that say about our existence and consciousness? It could lead us to question the very nature of reality. Are we living in a projected reality? If so, who or what is projecting it? These questions might seem like they belong in the realm of science fiction, but if the holographic principle is true, they become legitimate scientific inquiries. We might also have to grapple with the idea that everything we perceive as real, our bodies, our planet, the stars in the night sky, is just a projection on a 2-dimensional surface. It's a mind-bending concept, to say the least, yet even if the universe is a hologram, it doesn't make our experiences any less real. Our emotions, our thoughts, our dreams, they're all genuine. They're part of our human experience, and that's something that no theory can change. Whether a hologram or not, the universe continues to be a source of wonder and mystery. Regardless of its true nature, the universe will always captivate us with its beauty and complexity. It will continue to inspire us to ask questions, seek answers, and strive to understand more about the world around us.
Please do like, share, and subscribe to my channel. Thanks for watching.